Let us do another question. In a region, potential energy of a particle of mass 2 kg is given by u equals to 3x square plus 4y square. Find the acceleration of particle when it is released from 1 1. Now this solved example is similar to the previous that we did. Instead, the only difference is the previous one, the entire potential energy was along the x direction only. It had only x variable, but here it has x and y variable both. So in this, we are going to use the del operator. In the previous one, when the potential energy was only in one variable, was in just one dimension, we used simple differentiation of potential energy. Here we will use del operator. So we have already studied that del operator is minus F equals to minus del u. So it will be equal to minus del u by del x I cap plus del u by del y j cap, and there is no z component in it, so we will not have a k cap. Now this force, if we differentiate this, then 3x square will be differentiated with respect to x, so it will be equal to 6x. So 6x I cap. When you differentiate 4y square with respect to x, then it will be treated as constant, so 0. Similarly, when we are differentiating with respect to y, the first term will become 0, it will be constant, and the differentiation of second term will be equal to 8y. So this will be equal to 8y j cap. So this will come out to be minus 6x I cap minus 8y j cap. This will be the force. It is in vector form, so we will use vector sign. Now for the coordinate 1 1, the coordinate are given 1 1. For this coordinate, the force will be equal to, we put 1 in place of x and y, so it will be minus 6 I cap minus 8 j cap. This will be the force. Acceleration equals to force upon mass. Since we have vectors, so we will use vectors. That means acceleration will also be obtained in the form of vector. So it will be minus 6 I cap minus 8 j cap upon mass is given as 2 kg. So 2, it will be minus 3 I cap minus 4 j cap. So this will be the acceleration vector. Now although it is not given here whether we have to further solve it to find magnitude and direction, but let us just assume that if everything about acceleration is to be known, then second thing that will be the magnitude of acceleration. The magnitude of acceleration will be equal to root of 3 square plus 4 square, which will be equal to 9 plus 16, so 25. So it will be 5 meter per second square. Now if we draw the coordinate system, if we draw the graph, then the x component is of acceleration is at minus 3. So that means it is still here, let us say minus 3, and the y component is in minus 4 direction. So here let us say minus 4, and the resultant, this 5 meter per second square, this resultant will be in this direction. Let us say it is making an angle theta with the horizontal. So in this case, theta will be equal to tan inverse of perpendicular by base. So if this is minus 4, this will be minus 4. So minus 4 upon minus 3 or 4 by 3, and this comes out to be approximately 53 degree. So we can say that the resultant, the resultant acceleration is at 53 degree with minus x direction or with minus x axis.